precision measurement. Make sure you follow along, okay, guys? Okay, some definitions first. Accuracy. Okay. How close can I just go measurement like that? Can I shorten it? I think you'll be okay, right? How close the measurement is to the target. So if you get a piece like this, a 5-inch piece of pipe, that's the target, and you measure it, are you close to the 5? Like, accuracy is how close you are to that actual 5-inch, okay? And then how can it be affected? What do you need to be accurate? There's two things that you must have is you need an appropriate scale. What does that mean? You can't use kilometers to measure the thickness of the book. It'd be bad, right? And what's the next one? Standard unit. What does that mean? No body parts. Let's just put it that way. You can't use your span, your arm, foot. You can't use that. That would not be good. You would want to use cups, spoons, right? Teaspoon, meters, centimeters. All of that is good. How can you mess it up? Affected by improper use or damaged equipment. So if you're using a measuring tape that's all bent, extreme example, right? There's a ruler right here. That'd be a bad one to use. Or you leave it in the sun and it just warps like that. Not don't want to use that. Using a wet cup to measure flour, not a good one. You're not leveling off when you're baking, not a good one, right? So, and why is accuracy important? There's always some, you got to be able to justify it. It's important to be accurate with the amount of sugar, because if you're not, it's going to be too sweet. If you're too low, it's not going to be sweet enough. Like, just read the context and answer accordingly. Why is it important to be accurate when making a drug prescription, right? Or if you work in the pharmacy, well, if you're giving too much, you might overdose. If it's not enough, it won't be effective. Okay, next, precision. So I'm gonna actually just say this: precision is the smallest increment of measure. Like, what is the smallest this device can go up by? And I'll just give you examples here. Let's say you have something that measures 12.25 millimeters. Okay. What would be the precision of this device? We don't know what the device is. We're just assuming the precision is right here. That's where it's found. So what would you answer here? 0.05 and 0.01. We're assuming that the device that was used, right, that it can go up by 0.01 at a time. That's like the smallest amount it can go up or down by. Does that make sense? Okay, next. Another example. If I were to give you a ruler, and I'm just going to give you weird examples, so if they do something funny, you're going to know. What's the precision of this thing? There's a picture here. How much am I going up by from marking to marking? 8, right? I hope I got it right. I just made it up. It's 8. Yeah. Oh, let's put centimeters on the ruler because there has to be units. And so that'd be 8 centimeters. And last but not least, what if you're given a container to measure liquids? This one is quite popular, by the way. Gauges, right? A speedometer, temperature. So let's say this is 2, then there's no number, and you've got another number that says 8, and this is in liters. What's the precision there? You're like, I don't know, I'm trying here, Mr. Dirksen. Like, is it 2? Well, if it's 2, then it should be 4 here, and then it should be 6 here. It's not 2. Some of you are figuring it out right now, but if it's really hard to guess, high minus low divided by gaps. I hope you can see that. High minus low divided by gaps. So in this case, precision would be 8 minus 2. So you grab 2 numbers. Make sure you do the top first. How many gaps are there? There's 2, right? 2 gaps. So precision is 6 divided by 2, which is 3 liters. Let's try it. So 2 plus 3 would be 5. 5 plus 3 would be 8. That works. So if you do this and you get a number, try it out, see if it actually follows through. Okay. Next is uncertainty. Uncertainty is often known as the margin of error. In other words, the amount a measurement can be off by. Uncertainty is the amount that you can be off by when you look at a measurement. Mathematically, uncertainty is what? Precision divided by 2. And usually we precede it with the plus or minus, even though it's not a requirement. You won't lose marks if you don't have the plus or minus. This is important, very important. Make sure you have this on your study sheet. So let's do the uncertainty real quick for all the examples we just did. Uncertainty would be 0.01 divided by 2. That's plus or minus 0.005 of a millimeter. Uncertainty here would be 8 divided by 2, so it's plus or minus 4 centimeters. On the last one, uncertainty would be 3 divided by 2, so that's plus or minus 1.5 liters. Sorry. I hope you can see that that's 1.5. But there you go. So every measurement has its uncertainty. That's all I'm going to say for this section. So I'm kind of like going through the way I taught it. Next would be measurement. Stating it, right? Measurement plus or minus uncertainty. Okay. So the question may ask you to state a measurement plus or minus its uncertainty. So to be honest, we just kind of went through that up here. If this is your measurement, you go through some steps to get your uncertainty. Now you can kind of write them together like this. Okay, so, and because of the plus or minus, what does that really mean? It means that the measurement, you could get a max. Can I just say max, add them, min, subtract them? You know what? I'm just going to go plus uncertainty. Min, you go measurement, minus uncertainty. So this is saying, plus or minus is saying, hey, you could have something that's as big as this or as small as this. Okay. So you just have to kind of follow, is it adding or subtracting? You're going to have to decide that. So for example, let's say the province does this. They say 3.5 inches, write it like this, measurement plus or minus uncertainty, stated like that. We're going to go on a detour. We're going to say precision is what? If it's a measurement, it's always something 0.1, like 0.01, 0.1. In this case, it's 0.1 of an inch. Uncertainty is 0.1 divided by 2. So that's this. And now we can state it. We're just writing this down. State it. 3.5 inches plus or minus 0.05 of an inch. So they may ask you to state a measurement like that. What's the max? Mental math, right? 3.5 plus 0.05 is 3.55. The min is 3.5 minus this. This is 3.45 of an inch. Please read the question carefully though. It may be that all it's asking for is this. You're done. But it may ask you, based on this answer, what's the longest piece of lumber that you may have, or the shortest piece of lumber? Then you go min, right? So you got to watch out for that. Let's do one that's a little scary, but you can totally handle this. If they ever do this to you, I hope they don't. 12 and 1/8 of an inch. State that plus or minus its uncertainty. Chin, 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 right? Fractions, no problem. Convert. That's 12 and something. Figure out what 1/8 is. So 1 divided by 8 is 0.125. So that means that this is 12.125 of an inch. Just use the units they are giving you. So let's go on our detour. What's the precision here? How many decimals? 1, 2, 3, right? So precision is 0.001, which tells us that our uncertainty is 0.0005 of an inch. So now we can state it. 12.125 of an inch plus or minus 0.0005 of an inch. Scary, but not. You have a calculator. If you didn't have a calculator, maybe you had a bit of a point, but you just stick with that. And you can get your max and min from that. I'm not going to do it in this example. Moving forward, we're almost done, guys. Next, it has to do with this, but it's called, I call this section combined uncertainty. And what I want you to know under this is always add uncertainties. Involves multiple measurements. Exclamation mark. So let's see if I can give you an example that can quickly tell you what is involved. I'm going to try my best, okay? Let's say you have, there was one year, there was an example of a fence around the house, and they gave you the measurements and the uncertainty. So they said that this was 2 meters plus or minus 0.2. This was 4 meters plus or minus 0.3. And this was 2 meters plus or minus 0.2 again. What's the total combined length? Sometimes they say combined, sometimes they say total. What would you do there? I like to stack. So I take that measurement and its uncertainty. I grab my next one and its uncertainty and another one. And just add up both columns. So 4 and 2 is 6 plus 2 is 8 meters, plus or minus. This is 0.5, another 0.2 is 0.7. Boom. That would be the combined length and uncertainty, okay, of the fence. That means that the longest possible fencing would be 8 plus that, 8.7 meters. The shortest amount of fencing I would need is 8 minus 0.7. What is that? 7.3 meters. You know what? I was able to do this in less space than what I originally had, so I'm going to give you one more here. I'm making this up. So let's say you have a bucket with water, and one liter, 2 liters, 3 liters. It's all in liters. And you have a smaller one. It says 0.5 liters, 1 liter. And let's put let's assume the water is right up to the 1 liter mark here. I'm trying my best. So what would the amount in here, what would that be? 3 liters plus or minus. What would be the uncertainty here? Hold on. What do I need before I come up with uncertainty? I need my precision, right? What's the precision of this bucket? From marking to marking, it's 1 liter, correct? So that'd be 0.5 of a liter would be my uncertainty. Here I have 1 liter of water, plus or minus. I need to figure out the uncertainty. The precision on this one is 0.5 because I go up by 0.5. Therefore, the uncertainty is 0.25, correct? So I go plus or minus 0.25 of a liter. And you got to know, even if you were to pour this into this container, what happens to the amount of water that's in this one? It gets reduced by a liter every time, correct? But the uncertainties would still add. Okay, 3 liters plus or minus 0.5 minus 1 liter plus or minus 0.25. So this is what I want you to have here. That you put 2 liters in here, but you still add this. That's 0.75 of a liter. And I've probably given you a kind of a complicated example there. But we're just going to write you're pouring into small container. That's what's happening here, and that's why we use the negative there. But we always add uncertainties up. We always do. Okay, there's the one example. There are several examples on the exams where you're having the same piece of wood and you stack them 40 times next to each other. It's that exact same piece of wood 40 times. So instead of adding 40 of these, don't do that. Then you would just multiply, right? 40 times 2 and 40 times whatever the uncertainty is of that piece, and then you get the combined. Okay? So don't be thinking it's always adding, but that's the most common one. All right, now we're going into tolerance. And then we're done. Tolerance, and then we're done with precision. That's it. That's all you need to, in a nutshell, that's all you need. Okay. Am I going to be able to cover every scenario? No, I can't. You're just going to have to read carefully, very carefully. And I'm going to post this video as soon as I can. And if I talked about something you didn't catch, come and take a picture of this later on. Okay, tolerance. What is it? And I'm making this up, okay, like I'm freelancing here, so it might be slightly different than what you have on your study sheets, but it's the variation allowed for the object or piece, okay, to still be acceptable for its intended purpose, right? So you're making a piece, a window, you're making a car part, you're making something, and we almost guarantee that it's going to be a little off, correct? So tolerance tells us how much can we be off by and still be able to use that piece for its intended purpose. Okay. So the best picture I like to give you is that there's a max and a min. This is different than uncertainty. Okay, there's a max and a min allowed, whereas uncertainty tells you how much you could be off by using that device you're using. Here's like, this is the biggest you're allowed, this is the smallest you're allowed. The difference in there is what we call tolerance. Tolerance is always max, subtract min. Make sure you have that one written down. Mathematically, that's how we find it. And where is it located? Like on a picture, you would think of it this way. Anything that's outside, either on the low end or on the high end, would not be acceptable. We would consider that bad. Okay. Remember the examples I gave you? Grocery store, like their cooler in the back where they keep all the milk, right? It can only get this low, because if it's too low, then it will freeze everything. If it's too high, it will spoil everything. So you got to watch out. Read the question. For drugs, right? If it's too low, it's not going to do what it's supposed to do. If I only take half a Tylenol, it's not going to do anything to me, right? But if it's too high, it could be dangerous, right? It could be damaging. Okay, so here's what I want to say to you about this. There's 4 ways to state, but I'm sort of lying to you. You'll see in a bit. The first one is the max and the min, like you just have 2 numbers stacked. Okay. Then you have where the max is given, you can't go any higher, but you can go a little bit lower based on the tolerance. You have the minimum, which is the lowest. You can't go any lower, but you can go a little bit higher. And the last one is the nominal, plus or minus 1/2 of the tolerance. I like to think of it this way. These 3 here, so let's cover maximum. These 3 always have 3 numbers potentially showing up. This one only has 2. Okay, so for these 3, we know that the nominal is always found at the front of the number. Even though it could also be the max, it could also be the min, it is always the nominal. It's our target. Write target under nominal, because sometimes that could be a multiple choice. Nominal is considered the smallest increment. No. The target measurement. Yes. Okay. So there we go. Nominal is the target. How do you get the nominal out of this one right here? I don't know if you have that on your study sheet, but you got to add the max and the min and divide it by 2. But it's only this one, okay? Only this one requires that. Do not use that formula for any of the other formats. We're almost done here. So examples. We're going to close with some examples. What should I use? Like a unit that you haven't seen yet. Well, decibels is somewhat. So let's say you have 70 decibels, 40 decibels. Let's say the province says, hey, the measurement of a tolerance is this. Let's say they ask one of these 4 things. They ask you for what's the maximum, what's the minimum, what is the tolerance, or what's the nominal. They could ask you for maybe 2 of them, just 1 of them. It doesn't matter. We're going to do all 4. And here's the beauty of it. You can always answer these 4. And if you label them correctly, if you just want to answer, give me all 4, but they only ask for 1, you still get the marks because you were very clear to tell me which one is which. Does that make sense? It's more work, but you're going to get it. So what's the max? I don't know. Doesn't it look like this one? This one? So 70 is max, yes. Whatever you do, make sure you put the units down. Min, it looks like this one. So I know the bottom number is the lowest you can possibly get. Tolerance, yeah, it's 30. I know that tolerance is max minus min. I'm just going to show that here. And the nominal, I go to my study sheet. Oh, it's this one. I need to do this one. It's a pain in the butt, right? You got to do this. This means, folks, listen carefully. This is if the province says the nominal is halfway between the max and the min, they're literally telling you do this. When you add them and you divide it by 2, you're finding the halfway mark. Okay? So we're going to go 70 plus 40 divided by 2. That is what? 110, 55, right? So the target in this case is 55. The tolerance is 30, the minimum is 40, and so forth. Could you rewrite it now into any of the other formats? Yes, if you have everything you need to rewrite it in the other formats should they ever ask you to do it. But most 99% of the time they just ask for one of these 4. It's a 1-mark question, you know it's going to be one of these 4 that they're going to ask you. They just want to know, can you read this and figure out these 4 musketeers? I call them 4 musketeers. Okay. One more. And I think then I'll let you be. I'll let you do your thing. Let's do a weird one here. 27.8 millimeters plus 0.3 millimeters minus 0.1 millimeter. Sorry, write it down. So remember I said I'm sort of lying to you if these are the only 4 you're going to see? Does this one look exactly like, well, it's definitely not this one. But does it look like any of these here, any of these 3? It sort of looks like one of these here, but there's no 0, flat 0, correct? Don't panic. It is kind of following these 2. You can still answer this. Max, min, tolerance, nominal. Make sure you do this one. What's the max? Just add, right? Just add. Just go this plus that. That is 28.1. That's correct. And don't forget your units. Minimum, 27.8 minus 0.1. Yep. Tolerance, subtract them. Right? 0.4 millimeters is the tolerance. So that's what you're allowed to differ from this. And nominal. It's this big number up front. Okay? So nominal, I'm going to put an arrow. So essentially, if this company is using this format, they're like, we would ideally always be right on 27.8. A little bit lower, a little bit higher, right? But not much difference. Which one of these 4 are acceptable in this case? Sorry, my brain is frozen here. Hold on. Trying to do something here. Oh. Which one of these three is acceptable in this case? Is this one acceptable? Right, it's greater than my max. Is this one acceptable? 28.09. It's actually okay. It's a little bit less than this. If this throws you off, put a 0 here. It's technically 10, right? This is 9. So this one is actually okay. This one, you're a bit shorter than the, right? You got to look at this value here. This one is a little bit too short, this piece. So this one would also fail. Okay? So that's the idea there. That's it. Thank you. I'll try to make these ones more videos of this kind. Here's one more thing I want to tell you. The big three, right? The big three, the first one is you want to focus on vehicle finance. Equally important is home finance. I'd say those two are like a big chunk of the exam. Then you want to focus on trig and geometry, like they combine that. Geometry has your polygons, your classifying, right, all of that. And then everything else. Stats, probability, precision is everything else. But these are the big three, right? But precision measurement, don't forget about it because it does hurt you if you don't. And one more thing I'm going to plead. Whenever it says describe, explain, anything like that, do not leave it blank. If you run out of words, okay, give me an example. Give me a diagram. Try your best to somehow convey your point. Because guess what? This is I'm not going to record this because the province can fire me then.